All right. I want to look at 4B, number 1. Um, and it starts out by talking about 4A, number 10, which involved a couple of functions that I gave you. And it turned out that you could pick any point on F and find the related point where you switch the X and Y. And it turns out that that related point is going to be on G. So if AB is on F, BA is on G. And the way to visualize that on a graph is to just reflect the point right off the line y equals x. So it turns out that the follow up to that is, well, if I give you a whole functions equation, how do you get the inverse equation? And it's really the same exact process. In order to get the corresponding point on the inverse, you just switch x and y. So in the equation, you just switch x and y. And so there's an example here that's worked out where they give you an original function right here, and they say, find the inverse. So to find the inverse, usually you don't leave it as f of x. First, you switch it to just y. So if you look at this next one, it says another form of the original function. This is still the original function right here. Okay? Then to get the inverse, you switch x and y. So right here, if you notice, the y turned into x and the x turned into y, but everything else stays exactly the same. So this is the inverse now. Right here. This is the inverse. Okay? Now, if all I do is I say, give me the inverse, you're done, right? If you plug that into Desmos, it will graph it and it will be a reflection of this original line across y equals x. But normally people don't refer to functions in x equals form. Normally you write it in y equals form. So the goal is to now isolate the y. So if you subtract 8 on both sides, you can move the 8 over. If you multiply both sides by -3, you can get rid of that fraction. And then just rearrange it so that the y, just switch the sides. So y equals -3, x minus 8. Now, a common way of saying that, so all this right here is just different ways of writing the inverse. And inverse notation as a function is written as f to the -1. I can't tell you why it's to the -1, and you don't say f to the -1, you say f inverse. And the whole thing would be f inverse of x. Just like f of x, f inverse of x. So here's the original, and here's the inverse. And really, I often leave it in y form, especially if you're not sure if this final thing is a function. Later on, we'll talk about how you actually know if something's a function or not. For now, you don't have to worry about it. Okay. So let's take a look at A. Actually, I'm going to skip A. I want to do B. B's a little bit trickier. So the goal is to find the inverse of this thing. So first, I'm going to rewrite the original as y equals instead of k of x. And now I want to switch the stuff to get the inverse. So at this point, I just switch x's and y's. So y turns into x turns into y, and then on the bottom, there's another x that turns into y. Okay, and now the goal is to isolate y, which is not super obvious how to do the first time you come across one like this. In the top one, it was much easier because there's only one y to deal with. And here there's two y's to deal with, and they're not really together exactly. So what I'm going to do is I'm going to multiply both sides. I want to get rid of the fraction. So I'm going to multiply both sides by y plus 4. So x times y plus 4 equals y minus 1 over y plus 4 times y plus 4. And then the y plus 4's cancel on this side. So over here, I've got xy plus 4 equals y minus 1. So, whoops, not plus 4, plus 4x. I didn't distribute the x there, right? Because it's got to go to both terms. Okay, now I have some y's over here, right there, and I have another y term over here. So what I want to do is I want to get all the y's on the same side. So if I subtract that y over, I've got xy minus y, and then I'm going to bring this one over to the other side by subtracting it. So it turns into negative 1 minus 4x. And I still want to isolate y somehow. And at this point, the only thing that you can do is to factor out the y from this. X minus 1. Okay, so now we've got this. And at this point, we can isolate y by dividing both sides by x minus 1. So y equals negative 1 minus 4x over x minus 1. Which, by the way, that's a rational function. You could figure out where it's undefined. You could figure out where it's 0. You could graph this thing using a sign chart if you really wanted to. And I know you all do, but you can hold off for now because we have other things to do.